only one perfect solution, but there are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb and welcome to Faulty Chinese Counting. So, this module is based off of the original module Chinese Counting, however there is going to be something that is seriously wrong with it. And the way that you're going to immediately recognize Faulty Chinese Counting from Chinese Counting is the LEDs are going to be blinking 3 different colors instead of 1. That's immediately the way that you're going to know you're going to be having a Chinese Counting on the spot. Normally with Chinese Counting, what it would have here is it would have two LEDs that would be essentially in like a static state. They wouldn't be cycling through colors. And in this case, we're now going to be looking at faulty Chinese counting with a series of cycling different colors. And there is also the possibility of there being something seriously wrong with faulty Chinese counting. In this case, that can apply to one of these special cases below. One key has no label, which in this case is the one that actually does indeed ring true, because we do not have a label on this one right here. One key is cycling through 3 different labels. One LED is missing. One key disappears when the module is selected, and the way the selected works is specifically when you happen to be in this state. When you happen to select and focus on in this module here, it will immediately disappear, and the module can be also upside down. In this case, it does a whole 180, so that's going to be. So hopefully I'm going to be able to cover all of these cases today. Most of them are fairly simple, but one of the ones that I want to cover is going to be one LED is missing. So let's get right into this. I will only be doing about 3 examples. Most of them are easy to explain, and they are actually not too hard to see, not too understand. For example, the module is upside down. Each key's color is actually the one that is the key above or below it. So essentially, it's just going to be a swapping mechanism in this case. Overall, not too hard to understand. So let's get right into this. So now, what we need to obviously do is we need to figure out first off what's our order that we're going to be, what's the rule that we're going to be submitting these guys in, but also figure out what actually the values of each of these are. Because not only is it going to be in Chinese, there is also going to be some modifiers here that may change the value of what it actually is. In this case, black, red, blue, green, and purple. Black obviously is keep the value as it is, so keep that in mind. So let's take a look. So the way how Chinese counting works is essentially you're going to get a series of different numbers here. If you haven't seen Chinese counting beforehand, I would advise you actually look at my original Chinese counting tutorial. It definitely explains it, I think, well enough. And overall, it's not too hard to understand. Essentially, what these numbers represent here is you're going to see a lot of this plus here, which represents 10. And the way that multiples of 10 work, they are expressed with a number, expressed using a number, and then 10 afterwards. So, for example, 20 is 2 10. So in this case, we need to make sure that we have the 10 afterwards. And 100 is written as minus and that symbol right there. It does not appear that often, to be honest. And the 0 is written as the O right there. So this is the way that this model works. This will not apply that often, to be honest, but just keep that in mind that this actually only uses one symbol for 100 instead of 2 pluses, for example. That just doesn't make sense. So our first one here shows the displayed value of 7 for the first symbol, then 10. This represents 70. And then there's likely going to be something that's going to be afterwards, which represents the ones digit. So in this case, that's going to represent a 4. So this value is 74. We don't know what the top right one is, so now let's take a look at the next one. This one is going to be 37. We have 37 right there. And next up, this one is going to be 40, and then a 6, 46. Okay. So that's going to be this one right here. So now, how exactly do we get this value of the top right one here? One key has no label. So now we're going to consider the label to be the last digit of the serial number times the number of batteries modulo 100. Take the position of every other key's color in the list above, average them, round down, and count that many into the list. Into the list to find this key's color. So this is going to be how we're going to figure out the key's color. Obviously, the value itself is going to be fairly simple. Take the last digit of the serial number, multiply by the number of batteries, which in this case is currently 2. 6 times 2 is 12. Now, what we want to do is we want to take the position of every other key's color in the list above. In this case, all 3 of them happen to be blue here. So blue is going to be right here. So we're going to average them out, which in this case is simply just going to be 2 for each and every single one of them. And we're going to count that many spaces into the list count that many into the list to find the key color. So in this case, this is technically 3 on the list, so 1, 2, 3. And if you can already tell by basic math, the average works like this. It works as if you add up all the numbers together and then divide it by the amount of numbers that were present in this number. So in this case, if we take a look at the calculator, if I can find it, handy dandy calculator. Calculator right here. we have 3 plus 3 plus 3 divided by 3, because that's the amount of numbers that we're adding here, and we get a value of 3. So in this case, if we count from the top here, 1, 2, 3, we're going to get another value of blue. Fairly simple. So now exactly what do we need to do here? So with each of these values, the actual values of the keys aren't necessarily what is displayed. Use each key's color to determine its actual value. So let's take a look and let's see what we need to do. So the only rule that applies here is for blue, and blue is the value is twice the displayed value. So essentially we're going to multiply every single one that we have here by 2. So 74 times u by 2 is 148. 12 times 2 is going to be 24. I can do that in my head. 37 times u by 2 is going to be 74. And 46 times u by 2 is going to be 92. Okay. So now that we have our actual values here, note that we're never going to modulo by 100 unless it specifies. In this case, if it were a true value, we would mod 100. For example, if it happened to go over for some reason, it's very unlikely. You'd have to have a lot of batteries to do that, as well as a large serial number. But in this case, if it happens to ever go 100, this is the only time we're ever going to modulo 100. It never will be moduloing 100 by actual values here. That's going to be the way that this works. So now, in order to get what we need to submit, because we have our actual values, now we need to figure out the order that we're going to submit them here. So let's take a look. So using the color missing from the left LED as the row and the one missing from the right as the column, consult the table below to get an order in which to press the keys. So now our goal is, instead of finding the one that is currently in the static state, like in normal Chinese counting, we need to find the one that is missing from each of these colors here. Because as you can see, each of them are flashing 3 different colors, so we need to figure out which one is missing for each of them. So left LED is the row. We've got white, red, orange, white, red, orange, which is going to be missing green. That's going to be our row. And then the right is going to be missing, it's got red, green, and orange. It's going to be missing white. So now this gives us a value of C. And these rules are the exact same thing from Chinese counting. Ascending in value, descending in value, ascending in number of characters of the actual value, and descending in value of ties, and descending in the number of characters of actual value, and ascending in the value of ties. So in this case, this is going to be ascending in number of characters of the actual value, and descending in value of ties. So there's a lot of these that immediately represent 3 individual characters. We know that 148 is going to be significantly more because we obviously have to do this 1 and then this character, which represents 2 already. Then we need to do the 40, and then we need to do the 8. So that's already going to be 5 characters present from these. However, the rest of these are going to be simply 3. Because we have 24, 20, and then the 4, as you can see here. Then we have the 74, 70, and then 4, 70, 10, and then 4. That's the way that this works. So let's take a look. So the first things first is we're going to be noticing that we're going to be ascending in characters, and now what we're going to do is we're going to descend in value of ties. So we're going to start at the greatest value of these 3 right here, and we're going to start there. So it's going to be bottom right because 92 has the greatest value. Okay, the next step's going to be 74. The next step's going to be 24, and then finally to end ourselves off is the top left. And just like that is a solved module. So now let's load up a couple more examples. I'm going to do roughly 3 more. Hopefully we can get some of these cases here. But overall they are fairly simple to understand. The one that I kind of want to cover the most, and I want to make sure that I actually get this right too, is one LED is missing. That's the one that's going to be very, very important. So let's get into this, and hopefully we can get this example. Let's do 3 more, see what we get. A lot of these are fairly simple to understand. Okay, we got a module upside down. We have another missing key. We got 1 changing values. Okay, that's going to be good. Let's take a look. Let's actually reset. Let's get something that actually is a little bit more different. We have... perfect. 1 LED is missing. Perfect. We get to cover this one right here. Okay. I believe we have another key missing here. Yes, here we go. Perfect. This is another one I wanted to cover. So 1 key disappears when the module is selected. This is what happens. It's currently there. You can see it, obviously, when you don't select it. But when you select it, it will immediately disappear. That's the way that this works. Okay. And then what happens here is that using when one key is cycling through 3 different labels, use the label displayed when the right LED shows the left LED's missing color. So that's going to be the way that that works. It's fairly simple. It's not too hard to do. It's just trying to match it up at the right time. That's going to be the way that that works. Okay, let's get into this. So let's start with this one right here. I like the idea of starting with this one. So in this case, one key disappears when the module is selected. And if this key is one of the 2 left keys, press the right LED to press this key. Otherwise, press the left LED to press this key. So this doesn't change the actual work of the entire module here. All it simply changes is the fact that you now can press the LEDs as part of the submission here. So in this case, we're going to be pressing the left LED to press this key because it is not one of the left keys in order to press the right LED. So in this case, we're going to be pressing the left LED for this one. So we're going to do this normally now, and this is going to be quite fairly simple to do. We now just need to get the values here. We have, in this case, if we take a look here, that's going to be 67 for this one, 67 for the first one. Okay, then we just have 60 again. That's going to be just normal 60. Then we have 96, pretty big. And finally, for this last one here, we have 43. Fairly simple. Okay. Now we don't need to worry about this, except the fact that the color exists. So it is a blue. Okay. So now blue is going to be the value that is twice the displayed value. Fairly simple to do. 67 times by 2 is going to be 134. And we get 43 times this by 2 is going to be 86. Those 2 values here. Now we have a couple other ones that we need to address. And in this case, that's going to be red and purple. So we actually get to be able to almost see every color. I think we should be able to see green. Yes, we do. Okay. All right, let's take a look. So we get the red, the value is 100 minus the displayed value. Okay, so we're just essentially going to do 100 minus the 60 in that position, and that's going to give us a total of 40. And finally for purple, purple's a bit of a wonky one. The value is the average of all displayed values when you round down. So in this case, we're going to add up every single displayed value that we had beforehand, which means I probably should have done this first. But let's copy this for the sake of copying this. Let's back it up to where we had all of our normal values here. And now let's do this normally. So it's got 67 plus 60 plus 43 plus the 96. We're going to divide this by 4 because we added up 4 different values here. And that's going to give us a total of 66.5. Rounding down would be 66. So this is going to become 66. And I'm going to plug this back in here. This is going to be 66. Remember for this one, use the displayed values, not the modified values, the displayed values. And these are going to be our actual values here. So let's get this thing started. So we're going to do the same thing with the LEDs here. Which one is missing? White, green, red. It's missing orange. And orange, green, red is missing white. So it's going to be a hotel. Descending in number of characters of the actual value, ascending in value in type. Okay, so this one is going to be 5. This one is going to be 2. This one is going to be 3. And this one's also going to be 3. So we know that we're going to be pressing the 5 first. That's good to go. Note that it will immediately strike you if you happen to be wrong, and it will reset the entire thing, so just be careful with that. Then next up, we need to focus on the 2 3s here. It's going to be ascending in value of ties. 66 is greater. 66 is the lesser of the 2 here. So in this case, we're going to be pressing U first. Now, remember, we're trying to press the bottom right one, but it does disappear when we happen to be selecting it. So now, as we mentioned in the rule, if the key is keyed one of the 2 left keys, no, we're going to be pressing the left LED in this case. That's good to go. And finally, top right.
Is the right answer.
And just like that is a solved module. It still actually disappears when you solve the module too, which is quite funny. So now, let's get into probably the hardest one to explain here, and this is going to be one LED is missing. And this is very obvious when you see it too. So to start us off, let's actually focus first off on what the each of the values are, because these ones are actually going to be pretty simple to do. This is just going to be affecting the submission part of this module here. So let's get right into this. So we have for our first one here, we have 81, we have 95, we have for this one a 10 and a 7, that's going to be 17 for this one, and finally we have just 5, fairly simple. Okay, so now let's obviously pay attention because we do have a purple present, which in this case is going to be corresponding to the average of all displayed values. So let's do this again. So 81 plus 17 plus 95 plus 5. In this case, it's going to be 198. Let's hit that divided by 4, and it's going to be 49.5 or simply 49. Okay, now the last one I was not able to demonstrate here is green. Green is the value is the displayed value plus the displayed value of the key diagonally opposite this one. So the value is the displayed value plus the value of the key diagonally opposite from this. So in this case, we're going to do 95 plus the one that is diagonally opposite from it. In this case, is 17. So we're going to do 95 plus the 17, and that's going to be 112. And that's going to be the final value for this one, 112. Okay. And the blacks, obviously, as I mentioned beforehand, you simply keep the value as it is. We don't need to modify the top left and the bottom left ones. There we go. So let's take a look at now our quirk with this case. So one LED happens to be missing here. We're going to take the number of ports times the number of battery holders modulo 15 and then convert this into binary. So number of ports is going to be 0. Wow, okay, it's just going to be 0. Perfect. The number of ports times the number of battery holders modulo 15. So this is all simply going to be zeros in this case. Now, so what we're going to essentially do here is one thing that we need to note down is how the way that binary works here is it's actually very important to note that the binary numbers are considered to be 4 digits long, but take the position of the first bit that was originally that bit. For example, if 6 in binary is 110, padded that is 0110. So it's essentially adding the position to the position that is here, right here. However, you don't need this number, and the first 0 was originally in that position is position 4. The way that it works from right to left, in this case is what it's referring to right here, it represents the padded version. So in this case, the 6, how do I describe this? So if we were to do, for example, 5 is simply a 101, normally in binary. I would expect you to know how binary works, by the way, at this point. I'm not really going to explain how it works in this tutorial. So in this case, this is the lowest it can be, that it can be condensed to, if that makes sense. I hope that makes sense. And then padded would be essentially adding the 0 in this case to make it 4 digits long. Now, if you were to read from right, you would take that position from the leftmost 1, and this would be representing position 4. 1, 2, 3, and finally 4. Hope that makes sense. This is what it's going to be looking for here. So, if this LED is the left, if this LED is the left one, no, it actually is the right one here. Then take the position of the leftmost 0. If it's the right LED, take the position of the leftmost 1. Okay. So we're going to be taking the position of the leftmost 1. However, this bit actually is not present. We don't have this present in any position in this 0 because of the fact that it's simply 0. So if this bit is not present, use white. So this is the otherwise case, but essentially what's going to happen here is you need to essentially read from left to right, or you essentially need to read from right to left or whatever. But it wants you to make sure that you use the padded version for specifically position 4. So just be careful with that. This one is a bit of a wacky rule, but it wants you to take a look at the way that you want to read things. So that's going to be what you're looking for here. So if it happened to be 6, for example, if it happened to be the first 0, then that would be obviously taking position 4 for right to left. I'm sorry, this is a really bad explanation. But anyways, we're going to be using white for this one. And this one's going to be representing our column. So we're going to do red, orange, and green. That's going to be representing Charlie once again. We haven't gotten A or D yet, so in this case, let's take a look. Ascending a number of characters of the actual value and descending in value of ties. So we have ascending a number of characters. In this case, that's going to be not much, honestly. This is going to be 2. We can already tell that because of the way that it works. This one's going to be 3. This one is going to be 4, right? No, it's going to be 5, excuse me. And this one is going to be a 3 here. So ascending a number of characters, so we're going to start with you. And descending a value of ties, we have a tie here. So it's going to be descending, so we're going to do top left because 81 is greater than 49. Bottom right, and then top right once again. Okay. And I'm going to do this last example. Let's get this thing going, because this one is a fairly simple one to do. So let's take a look. This one is one key has no label once again, and let's take a look and see what we need to do here. So now we're going to consider the label to be the last digit of the serial number times the number of battery holders once again. this is going to be 7 times this by 3. So that's going to be 21. So this is going to be 21 over here. Let's get the values of the other ones here. This is, the bottom left one is a 1. This is going to be 24 for this one. And finally, the top left is going to be a 98. Okay. Now, in order to determine what the color of it is, we're going to take the position of the other keys, the keys in this label here. So we've got 1 black, we've got 1 red, and we've got 1 blue. So we have to do 1 plus 2 plus 3. We're going to do the average of this divided by 3. And what this is going to give us is this is going to give us position 2. Starting from the top, we're going to go 1, 2, and this is going to be the value of red. So that's perfect. That's all we simply need to do for this. So we've got 98. 98 is red. Is going to be the value of 100 minus the displayed value. 100 minus 98, pretty simple to do, is going to be a 2. And then we're going to do the exact same thing for the top right. 100 minus 21 is going to be 79. Black is going to stay as it is. We don't need to worry about that one changing at all. And for blue, we're simply going to double this display, which is going to be a 48. And these are our final values. Lovely. Okay. Now to submit them. So we have on the left here, we've got no white. And on the right, we have no green, which is going to be hotel once again. Jesus, I'm getting all the character ones. So we have 1, 1 for these two, obviously. This is going to be then 3 and then 3. Descending in the number of characters of the actual value, ascending in value of ties. So descending in characters, so we're going to be starting with these two. And we're going to be ascending in value in the case of ties. So 48 comes from 479, so we're going to press bottom right, top right, okay? And finally, descending in number of characters. In this case, we have this 2 1s left. And ascending in value of ties. We're going to do 1 and then 2. And just like that is a solved module. Apologies for my really scuffed explanation on the one LED is missing. If someone wants to clear it up in the comments, that would be perfectly fine. But in this case, we happened to get lucky with the case of 0. It wanted a 1, and then we didn't have that bit, and obviously we used white in this case. Thank you for trying to follow along with that. And as always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.